My name's Ted. I work at Lightstep on OpenTracing. And this talk is just, honestly, a bit of a ramble, a bit of a rant. It's some intro overview information about tracing in general and OpenTracing in particular, in case you never heard of it. And then we're going to dig into some more aspirational aspects that I've been thinking about and working on lately around how you can use tracing and the kind of correlation it provides to improve and change how you do metrics in a distributed world. So first and foremost, what is tracing? Why the heck should you care about it? The answer is microservices. So when we lived in the happy old golden era of one monolithic application container running all of your code in one spot on ideally one machine, we had a lot of great tools about telling you, the human, a story about what that machine was up to, what the requests were doing, what was going on in there. We really have quite a bit of tooling at the sort of server level, at the process level, at the Linux level. There's a lot of good stuff there that was completely laid to waste when we took our systems, broke them apart into small chunks, and moved them off to separate machines and processes. So before, if you had a request come into your system, you would hit your application, and you would have a stack trace, and you could look at that stack trace and see everything that happened around that request. But now, when that request hops from machine to machine to machine and then returns, if you want to see all of the stack traces related to that request, it's now a bunch of little stack traces that are spread around. And more you'll find if you want to make any sense at all out of your system, you have to start gluing and stitching those stack traces and other storytelling devices back together again, so that you get some kind of cohesive overall narrative back out of your system. And man, doing that manually, it just starts to become more and more overhead. Living without it, at small scale, you can maybe live without it and just sort of dig around in your logs, but once you hit any kind of moderate or reasonable scale, that just becomes ridiculous. There are too many logs to dig through, and it's too much work to try to piece them back together, and you need to have some amount of indexing and correlating going on just to be able to scope things down to see the stuff specifically that you want to see. And so solving that glue problem is really at the core of tracing. So that sounds wonderful. Why are we not doing this? I mean, tracing has been around for a really long time. Since we've had operating systems, we've had some form of tracing them. Distributed tracing showed up shortly after networks showed up. Most of the research kind of came out of the 70s, and there's been some academic movement on the subject, but not a lot, because academically it's sort of a done problem, and all of the issues with using tracing have to do with these sort of self-made problems around the actual instrumentation you want to do. And one place where it really shows up is specifically the instrumentation API. The way these APIs work, where if you want to trace your system, you have to have some way, like with logging, that you're entering these trace points into your code. And those APIs were always tied to some particular implementation. So you had a particular vendor would make a tracing system, and they would have an API, or it might be a language or a runtime. Maybe people in the Java world get it together and they're like, oh, here's a way to trace your Java stuff. But it's only your Java stuff. As soon as you add that Ruby on Rails front end to your stack, maybe people in Ruby went off and did some interesting work on tracing Rails, but those two systems don't talk to each other. So you're still stuck in this sort of fractured world, and there's no great way to tie it together. Unless you pick one canonical winner and you're going to say, I'm going to use this thing and I'm going to use it everywhere. And you might even say, hey, it's open source, so it's like I'm picking a winner, but I'm not tying myself to a vendor. I'm tying myself to an open source implementation. But that also falls apart, because a lot of this information and a lot of the places you want to be are in your libraries and your frameworks. And when you go to try to trace your libraries and frameworks, some system like gRPC, for example, you hit the same problem you hit with logging in your libraries and frameworks, which is if you're going to log, you have to pick a logging tool you're going to use. You're going to have to pick a logging format that you're going to be putting it out in. And this results in something that nobody likes, right? Which is libraries spewing logs in some random format to standard out where you never wanted it, and not integrating with the rest of the logging that you're doing in your application. And the answer, like logging, is you just don't do it in libraries and frameworks. The rule is like, don't do it there because you don't know what the right choices are for where that information is going to go and what format it should be in. And so for those reasons, tracing has been somewhat of a non-starter and hasn't taken off as much as it probably should have, considering how long we've been doing service-oriented architecture. Like, this is not actually a new thing. All right, so this is where OpenTracing actually comes in. It's a very fast-growing project. The V1 of the spec showed up just a year ago. There's already a number of tracers that bind to it. Zipkin, for example, is a gold standard Dapper-like tracing system. Similar to Zipkin is Jaeger from Uber, which is a sort of new OpenTracing native tracer. Hawkulars from Red Hat sitting on top of Jaeger. There's also AppDash, Lightstep, where I work, SolarWinds. A bunch of other people have already started to bind to it. And if you look at the wall of logos, you can see that it's already starting to penetrate the industry fairly significantly. So even though the project is very, very young, adoption is moving very, very fast, mainly because there's such a strong and growing need for some kind of standardized glue to bring all this stuff together. So here's how OpenTracing gets around adoption issues that previous systems faced. First and foremost, it's an open and standardized API. It's standardized under the CNCF, along with Prometheus and a bunch of other great tools, Kubernetes. And it's truly open. And by open, I don't just mean it's open source. I mean it is vendor neutral. So anything that would be specific about how one particular tracer might work over another one, anything that would make some tracers inefficient while benefiting some other tracer, we've done a lot of work to smooth over those wrinkles. So if you use this API to instrument your code, you no longer have to worry about those collection questions. So you use the OpenTracing API and instrument your library or framework, either directly or through a plugin. And when you do that, all you're doing is just recording the semantics. This is the semantics of what happened. This is how it happened. For anything that could happen that is standard and universal, like HTTP response codes, for example, we have standardized names for those things. So everything is standardized and decoupled from the other questions that you want to answer, not at the instrumentation level, but at the application level around what collection system do I want to use, where do I want it to go, which of these semantics do I want to collect. And by pulling those two things apart, you're now able to go into all your libraries. You're now able to really just focus your instrumentation on the semantics and not worry about the collection, and let the collection worrying occur at the sort of deployment, the deployment application init time. And that was what sort of finally broke the barrier and has started to create a lot of widespread adoption around this concept. So here's the basic architecture. Another way of saying architecture would be a model of computation, because that's really what OpenTracing is at the end of the day. It's a way of looking at everything your system is doing it and describing that computation, that parallelism, all of that concurrency from the perspective of distributed transactions. So rather than describe the specific details of everything that's going on, you just want to know what your system is doing in terms of distributed transactions. And there's a bit of nomenclature here. So you can think of every operation, group of function calls that represent some cohesive subsystem. We refer to that as a span. So a span is basically a name associated with a start time and a duration. And then you can start tagging that span with pieces of information. So tags are key value pairs that you attach to the span, and that's how you get all of that sort of indexing information that you're going to want later in your kind of metrics and alerting systems. The other thing you can do off of spans is log. So there's a logging API. This is just straight structured logging. But rather than just logging in the ether, your logs are now being associated with spans. So that means when you log against this API, all that correlation information could get injected into those logs as well. So logging is an important part of this. When you hit an RPC boundary or any form of serialization you need to do, RPC, message queues, any of those kinds of things, you have an API for injecting and extracting what's referred to as the span context from the headers or metadata part of that RPC call. So if you're making an HTTP call, you get to the point where you make that call, you get the current span and say, hey, inject this span into this HTTP header. And again, the way that's structured in the API, it makes a point to not say anything about what that metadata might be. So there's a lot of room for individual tracing systems to have their own standard for propagating data across the wire. This actually kind of confuses people when they show up to OpenTracing because they're like, where's the standard wire protocol? Where's the standard implementation? Where are the things? And the answer is always, well, this is the API. Go somewhere else to pick the implementation. So if you guys do go and look at OpenTracing after that, just keep that in mind. You're going to look at OpenTracing to get this information, and then you're going to pick Jaeger, Zipkin, Lightstep, some other system to actually implement it. Another important piece of information here is baggage. So one thing you can define on your spans, in addition to tags, are pieces of baggage. Baggage, again, are just key value pairs, so they're no different than tags. The key difference is baggage is propagated. So child spans inherit the baggage of parent spans, and when that span context is serialized, it carries the baggage across the wire. And so this is a place for you to put application-specific correlation information into your system. So think user IDs, project IDs, all of that kind of stuff that the tracer itself wouldn't know about it. That's something specific to your application, but it is some important index or dimension that you want to be using when you're creating metrics later. And then, of course, the final API is the tracer API, which is what these various solutions then plug into. And there's, of course, your standard tracing vendors at this point. But in addition to those standard tracers, people are building more and more kind of bespoke tracing systems. I say tracing in air quotes because the most common thing you're doing, I see people doing with OpenTracing, is, well, I was doing a bunch of logging, and now I want to add correlation IDs to all of my logs. And so what I want to do is have a very basic tracer that all it does is propagate that baggage and span context along the wire, and then I want to log through it so that every time I write my log, it just pumps that correlation ID in there. And the way people can do this is if the way you're logging currently is through some kind of interface-like API that's not too tied to a specific implementation, like glog or something like that, you can have all that happen under the hood. And so without going in and re-instrumenting all the logging in your system, set up something where all the logs just sort of magically get a correlation ID. I'm happy to talk to people after the talk about the specifics of that, but that's an example of something that's not like a standard tracing solution, but just homegrown things people are building to hop their system from having no correlation to everything being correlated without having to rewrite everything. And the other place relevant here is also using those APIs to pump information into metrics solutions like Prometheus. I just went through logging. as a way of like injecting correlation IDs into your logs. Metrics and alerting, of course, is like very common as you're having spans finish with tags. You want to use those tags to create metrics, increment counters and gauges, set SLAs, all of the standard things you're kind of doing with standard metric systems. People can use OpenTracing for that. Context propagation, just general purpose way of being able to propagate information down your stack rather than go to each call site. You just have this general purpose way of doing that. So that makes it easier. Critical path analysis and systems topology. This is more like traditional tracing. Critical path analysis is if you look at all the operations, this tree of operations that occurred in this request, and ask, how do I decrease the overall latency of this request? So this request is latent, and I would like to know why it's an outlier and what I need to do. Where should I focus my energy on optimizing the call stack for this request? And so that having the system be able to do some analysis for you and actually point you to the specific operations that would be most beneficial to optimize to get the lowest overall latency, that's, I would say, probably the number one thing people use tracing systems for today. Another growing use is what I call system topology analysis, where the issue you're facing with things being slow is not that the particular code involved with that particular request is slow or inefficient, but rather that request, when it runs, is running on shared machines using shared resources with other requests. So your request might be totally fast, but then it gets stuck in a queue behind some other request that's super slow. And that is the kind of thing, if you're just looking at logs, it can be really difficult to see that sort of slowness happening in your system, because it's nothing to do with the specifics of that request. It's just how that request is interacting with other requests on these shared resources. So that's another growing area of use for tracing systems. You can see by having this API that's just describing the semantics of your system, but not talking at all about the collection mechanisms or any of those details, but has a logging API, has all of the tags that you would want to generate your metrics for on it, and has all of the sort of correlation and propagation glue that you need to do these other forms of analysis. It starts to become sort of a universal instrumentation API. This is a little aspirational with the current API, but I think once you start doing this in your system, it becomes obvious very quickly, because you'll end up with all this crazy duplication where you have some line of code that you want to instrument, and so you're like, go get the span, go add some tags to the span about this piece of code, go log on the span, now go log again against your logging thing, now kind of take those same tags or something similar to that and increment some counters. Like the stack of instrumentation code, once you start doing, logging, metrics, and tracing together, it just starts to look really ridiculous and starts to look very, duplicative. So I think if you start to do this, you'll start to be like, well, why am I doing this 3 times? I could just do it once through this universal API and then rejigger how my metrics or logging solution is working so that it's just pulling information off of that API under the hood. So rather than instrumenting everything 3 times with 3 systems, you instrument with one neutral API and then pipe it out to 3 systems. And I predict you're going to see more and more of this approach as these sort of APM solutions start to grow and become more standard. I think the Open Census, Google Census project is an example of an implementation that's trying to sort of do this. They're not open tracing per se, but it's an example of trying to pull that off. And the other great thing that you get is because we can now go instrument all of these libraries and frameworks, and these libraries and frameworks and service clients actually represent the edges of each process and the places where the processes are interconnecting. you have this really wonderful thing where if you want to actually get your system up and running and traced really quickly, rather than going in and actually writing a lot of code to instrument your application, there is a GitHub organization called OpenTracing Contrib, where we have just scads and scads of library and framework instrumentations. So if you're using anything that's sort of standard open source, we've got a growing set of instrumentations for you to pick and choose from. So you can just quickly install, if you're using gRPC, Rails, a couple other things, just for each language stack that you have, install a couple of plugins, install a plugin into your proxy. We have, Nginx, Envoy, a bunch of proxies let you plug stuff in at this point. And also iOS and Android clients, things of that nature, and instantly get a very high-level overview of your whole system. And then off of that very high baseline, you can then start to go in and add more and more spans and get more and more application specific. But you can get up and running very quickly without writing a lot of code just by installing all of these plugins. And so that is, I would say, a big advantage that OpenTracing has right now, and that's like one of the main things that it has to offer. The other thing I see people doing with OpenTracing is they're not sure which tracing solution or vendor they want to go with, and so they're just starting with OpenTracing when they do this, and that allows them to kind of pick and choose and not be stuck in this situation where they want to change vendors and now they got to rip everything out. All right, so now we're going to move on to a little more aspirational part of the talk, talking about how you can actually integrate your metrics system into your tracing solution. Because the thing about metrics is not quite tracing, right? Metrics, the correlation, glue, all of that. Your metric solution doesn't need to be involved in any of that stuff per se, but it does need to get this information piped into it as it flows by. So where's all that at? How do I have my donut and eat it too? And first of all, what information do you have available? What information do I see people creating metrics out of? Well, the operation names for each span are gold. Getting all of your requests into your metric system and then being able to index or add dimensional data using the operation names works very well. Span duration, like latency information, is really useful for setting up, SLAs and alerting. That's often a thing you want to alert on. Errors coming off of the tags is another thing you want to alert on. And then, again, using baggage and things like that to add more indexing and dimensionality. So most of the things you would want to make a metric out of, you could most likely use the OpenTracing API to get that information. So the next question is, how do you actually integrate that with your metric solution? And the approach we're looking at right now are observers. So being able to add these observer interfaces, it's not the core tracer that's doing the propagation, but anytime one of these events is occurring, you have an observer that's then hooked up to your metrics system that's getting those events and piping those metrics out. And there's a couple projects in the work. There's a specification issue discussing observers in general. There's a Java metrics project that's sort of looking at metrics for OpenTracing that's Java specific that people are looking at. And there's a Go observer that people have written. So this is all kind of new. There's some things I'd like to see changed about the API to make building these observers a bit easier. But this is sort of kind of ongoing in a sort of experimental stage at this time. Here's just sort of a concrete example just to show how little code is needed to hook all this up. I don't expect you to need to read all of this code, but this is like a running example that would work with the Golang basic tracer that's hanging out in OpenTracing and connecting it up to Prometheus. So this is something that takes every span that comes in when it's finished and creates a latency metric that's labeled by span operation, where the value is the duration. And then if it finds an error, then it also increments a counter on that error type. So you can see, like, It's not a lot of code it's simple, but it's really not a lot of code. There's not really an impedance mismatch for doing it in this style. Some things I'd like to see, some changes I'd like to see in OpenTracing, some things I'm working on and I'm hopeful about, is exposing some of these IDs that we know systems have, but we don't expose to the API right now. And those are the things you would want for correlation IDs. We want to see more concrete examples of bindings. Some people have been binding OpenTracing and Prometheus together. I would like to see more work on that front, more work with Grafana, other solutions. So if you're interested in this kind of thing, that's absolutely a place where you can kind of come and join and play around with people. And the final thing, I'm not currently working on this, but I think would be really cool, is some kind of declarative metrics format. Because if you think about what we've done, we now have, like, you're no longer worried about instrumenting your code. That's all standardized, right? So you have standard semantic instrumentation happening over here. You have some plugin that can plug into that that's just going to pipe whatever metrics you want into your metrics solution. And then you have to define the metrics themselves. And once you've split it up in that manner, well, you can define all those metrics in one spot now. And if you're going to go sit there and define them all in one spot, why not do that declaratively? And I don't quite know what the best syntax for that would be. But to me, I'm fairly certain I would prefer to have all my metrics in one spot. And anytime I want to change the metrics coming out of my system, I just add a line to declarative file. And I could also see that becoming standardized itself. So there's the Open Metrics project happening right now that's looking at standardizing the Prometheus wire protocol. They're not looking at this kind of a format, but I am kind of hopeful that you could come up with a more standardized declarative metrics syntax. And then your metrics would also be kind of decoupled from, you want to swap out Prometheus for some other collection system, you don't go in and rewrite all of your metrics, right? It can just read out of this declarative file. So that's my super aspirational thing. If anyone is interested in that, please let me know, because I think that would be lots of fun. This is just a big ask. If you find any of this stuff interesting, I encourage you to go play with the OpenTracing API. Hop into our Gitter. We've got a Gitter that's live and bumping. There's people in there all the time to answer your questions. If you go to GitHub, there's plenty of instrumentations we had, plenty of issues to get involved with. There's a lot of work being done right now to bridge OpenTracing and add it to Kubernetes and other big systems that we're using. So if you're interested in any of that, you should come hang out with us. And that's it. That's my talk.